In this video, we'll look at the second of our matrix transformations, reflections. So our general principles still hold. That is that when we're constructing our transformation matrix, we develop the first column of our 2 by 2 matrix by considering what happens to the point 1, 0 under the transformation. And then we develop the second column by considering what happens to the point 0, 1 under the transformation. And then we put those together to get our final transformation matrix. So we're going to create a matrix which defines a reflection in the line y equals x tan theta, where theta is the angle formed with the positive x-axis. Now bear in mind that this matrix will only hold for lines which pass through the origin. So let's consider first the point A, 1, 0. And when that is reflected in the line y equals x tan theta, it ends up at the point A dash, which we'll denote with the coordinates x, y. And it's worth noting at this point that the angle in the triangle that we'll be using is 2 theta. The original theta from y equals x tan theta plus that same theta again because we're investigating a reflection. So the angle will be 2 theta. So cos 2 theta equals adjacent over hypotenuse. So the green line is what we're investigating. Cos 2 theta equals x over 1. So x equals cos 2 theta. Now we'll look at the red line, the y coordinate of A dash. So sine 2 theta is opposite over hypotenuse. The opposite is y, and the hypotenuse is 1. So y equals sine 2 theta. So the point A, 1, 0 maps onto the point A dash, cos 2 theta, sine 2 theta. So we have the first column of our reflection matrix. To get the second column of our matrix, consider the point B, 0, 1. Now, this is a lot more complicated than the first column, so we'll take our time here. So the point B, 0, 1, when it's reflected in the line y equals x tan theta, is reflected onto the point B dash, which again we'll denote with the coordinates x, y. Now, this angle theta means that the angle formed here, BOK, angle BOK, is 90 minus theta. Now that means that the angle B dash OK, B dash OK is also 90 minus theta. But the angle that we're interested in is this one, this smaller angle, which is 90 minus theta minus that theta. And so we end up with the angle in the triangle that we're interested in is going to be 90 degrees minus 2 theta. So now let's investigate the x-coordinate of point B dash, which is denoted by the green line. So cos of 90 degrees minus 2 theta equals adjacent over hypotenuse. The adjacent side is x and the hypotenuse is 1. And so x equals cos of 90 degrees minus 2 theta. Now, cos of 90 degrees minus 2 theta equals sine 2 theta. So an example of that is cos of 60 degrees equals sine of 30 degrees, and you can investigate whether or not that holds for all values of theta, or particularly all acute values of theta. But we end up with x equals sine 2 theta. Now let's investigate the y coordinate of B dash, denoted by the red line. So sine of 90 degrees minus 2 theta, the angle that we're interested in, is negative y over 1. We'll get a negative value for y. So y equals negative sine of 90 degrees minus 2 theta. And similarly, sine of 90 degrees minus an angle is equal to cos of that angle. So y equals negative cos 2 theta. So the point B, 0, 1, maps onto the point B dash, sine 2 theta, negative cos 2 theta. And so we have the second column of our reflection matrix. And so a reflection in the line y equals x tan theta, where theta is the angle formed with the positive x-axis, is represented by m equals cos 2 theta, sine 2 theta, negative cos 2 theta.